Let's talk about polynomial functions. A polynomial function is a function of the form f of x equals a sub n x to the nth plus a sub n minus 1 x to the n minus 1 plus, and you continue until you get a sub 1 x to the first plus a sub 0, or sometimes called a naught. But what does that really mean? Let's look at some examples of polynomial functions. So polynomial function is a function that could be written in this form. So for example, f of x equals 9x to the 11th plus 4x cubed minus 7x plus 300. That's a polynomial function. Or f of x equals x to the 8th plus 5 over 3. Now it doesn't quite have that same look, but we could rewrite that, right? We could rewrite this as f of x equals 1/3 times x to the 8th plus 5/3, right? So now it has this look. Of course, we have some missing terms. There isn't a requirement that every term starting with the highest exponent down to the constant exists. Some of those could have coefficient 0. For example, here the coefficient of x to the 10th was 0 and x to the 9th was 0, and so on. But definitely these fit this model. Or how about a polynomial that looks like this? F of x equals x times x minus 4 times x plus 3. Now, although it doesn't come looking like this, if we were to multiply it out, we would see that we would have an x cubed and then some other terms that would fit in this pattern. Now, let's look at some functions that would not be polynomials. So something like this, for example. F of x equals x to the 3/2 plus 17. Polynomial functions have exponents that are positive integers. So an exponent of 3/2 means that this is not a polynomial function. Here's another one. F of x equals 3 over x minus 2. Not a polynomial function because the variable is in the denominator. That's not allowed for polynomial functions. And here's another one. F of x equals 6x to the negative 3 plus 9. Not a polynomial function because we have an exponent that is not a positive integer. It's a negative integer, but this polynomial functions always have exponents that are positive integers. And if we put a radical in, like the square root of x minus 3, also not a polynomial, because remember, a square root is equivalent to a exponent of 1/2. So this would be x to the 1/2 minus 3. And again, the exponent is not a positive integer. So this is the way our functions need to look to be polynomials. Let's talk about some vocabulary that you hear with respect to polynomial functions. Suppose we have this function, f of x equals 2 minus 3x squared plus 9x cubed. This is not a polynomial that is in standard form. Standard form would require that the function look like this. The term with the highest degree goes first. So if we were going to write this in standard form, we would just rearrange the terms. So we'd have f of x equals, start with that 9x cubed, and then write the terms in descending powers. So negative 3x squared would be next, and then the positive 2, and it's in standard form. Also very important when you're talking about polynomials is the leading term. The leading term is the term of highest degree. And if it's in standard form, it would be first. So this 9x cubed is our leading term. And the constant is written last, and the constant is the term that doesn't have any variables on it. It's just the plain old number. So the constant for this particular function is 2. The degree of this polynomial, I didn't list that, the degree is the degree of the term of highest degree, right? This is degree 0, this is degree 2, this is degree 3. We say the degree of the polynomial is equal to the degree of the term of highest degree. So this is a third degree polynomial. Let's do another one. Suppose we have f of x equals 1 minus 6x minus 3x squared over 2. So if we were going to write this in standard form, we're going to rearrange the terms, and we'll write each of the terms over 2. So f of x equals, now this term would go first, so I would have negative 3/2 x squared. Next, we have negative 6x over 2, which we would reduce and make negative 3x. And last, we would have 1 over 2. So this is a second degree polynomial because of this exponent. The leading term, remember, is the term of highest degree, so the leading term would be negative 3/2. And the constant is right here, this one without any variables on it, 1/2. Let's do one last one. Let's make it f of x equals x squared times x minus 11 times x minus 2. Certainly isn't in standard form, but let's multiply it out. I would start by multiplying the binomials together. So we have x squared at times, and you'd FOIL that out, and you'd get x squared minus 13x plus 22. And then let's distribute. So we have f of x equals x to the 4th. We're just distributing the x squared minus 13x cubed plus 22x squared. So our degree is right here, a 4. So this is a 4th degree polynomial. The leading term is that term of highest degree, so it's positive 1x to the 4th. And our constant, remember, is the term without any variables, and you look and you don't have one, so that means there's really just a 0 out here. So our constant would be 0.